Hi, my name is Gia, and for my Pset 4, I decided to use the data from the communication game project. I'm going to be answering some of these questions here. And the first thing we're interested in is how long are the text responses in general, and what distribution does it follow? So I found that they both follow, for both character count and word count, they both follow an exponential distribution, and they average roughly about 68 characters and about 14 words. Next, I want to know if longer texts lead to more accurate answers. I actually divided the data set between observations that were correctly matched and observations that were matched incorrectly. And there were 1775 observations that were correctly matched and 171 that were incorrectly matched. And in general, I found that the incorrect matches had a higher average of both character and word counts. So next, I want to know whether accuracy improved through the course of the experiment. So in order to represent time, I used the round number because you can see from round 1 to round 72 along the x-axis, and then I can see how many incorrect matches occurred where. So here I could see that in round 1, we had the highest number of incorrect matches, and it slowly decreases so that by round 72 over here, there's less frequent occurrences of incorrect matches. So that basically tells me that overall, as the experiment continues, accuracy tended to improve. So next we examine how the length of text increased or decreased as the experiment progressed. So I took the log of the character count so it would be easier to plot, and I plotted it again on the x-axis of round numbers. And we see that after fitting the linear regression line, that it generally has an inverse trend between the round number and the log of character count, which is to say that the character count seems to decrease as the experiment progresses. Now, I grouped everything by game ID so that I could see how the individual teams did. And although this graph is very difficult to see, you can still see that there's an inverse trend for each team, which is consistent with what we observed above with the overall. Now I'm going to look at how the textual similarity changed over time, and I plotted the Jacquard with previous occurrence along the round number x-axis, and I found that for the first 12 rounds, the similarity was 0, so things weren't similar at all. And after about round 12, which is after the first 2 rounds, people started to, become, the textual content became more similar. So I guess people were becoming more acclimated to the stimuli, and they were recalling the content they used for successful matches, so that we had a general positive slope here. And to see if it was random, I plotted the Jacquard with random occurrence along the x-axis of round numbers, and I found that no, this is very different. We don't see the same thing, so I can reasonably rule out that the first trend we saw here was due to random chance. Okay, now I want to know whether certain stimuli were harder to guess than others. So I calculated the mean for each object, and we have all the different objects here, and there's 12. There's A through L, and we have this ratio here of how often they were correctly matched. And by plotting them, I can see that object B was probably the most difficult as it had the lowest number of correct matches, whereas I and C both have very high ratio of correct matches. So now I'm going to make some plots. This is the relative to each object, it's whether what their character count was. And this graph is useful to me only because I can clearly see that object J has this really high outlier, which I'm going to take into consideration when I do my next plot, which is the average character count per object. And I can see that J has this very high average, like an average of 118 characters, but I also know there was this big outlier. So I'm going to take that into consideration when I do my analysis. Here I have a table that shows the objects and their average length in text relative to their average of correct matches. And now I'm going to plot these two against each other So here I have another plot with the average character count on the y-axis and the average ratio of correct on the x-axis, and I can see that there is an inverse trend, and that this is probably my object J, and this is probably my object B. And for this linear regression line, I used the geom smooth with the parameter being method equals LM, which gives you the same linear regression, although I did it normally earlier. And in conclusion, we saw that the length of text variable did not influence accuracy, but that accuracy tended to improve as the experiment progressed. We also saw that the length of text tended to decrease as the experiment progressed, both in general and relative to each team. We also noted that textual similarity of the content would increase after the first 2 rounds as participants became acclimated to the game. Certain objects appear more difficult to match, which also correlated with the length of text, as a greater average of correct matches for an object tended to correspond with a lower average text length. So the overall takeaway about language is that communication tends to improve with practice over time, and that familiarity can shorten the amount of words needed to communicate effectively. Thank you. Everyone, have a great summer.